Okay, ladies and gentlemen, this is chapter 2.8, writing fractions as decimals. Um, a couple of things you need to know. There's two vocabulary words: terminating a terminating decimal and a repeating decimal. So first of all, the terminating decimal. These are decimals that terminate. They have an end, like the Terminator. He's a terminator because he terminates things. He puts a stop to them. For instance, one of those fractions that you're supposed to know by half, 1/2, can be written as 0.5. It's terminating because it just stops. Basically, the best way to solve these, there's two methods, and we're going to look at both of them today. The first one would be long division. 1/2 is equal to 1 divided by 2, which is the same thing as 2 into 1. You can't do 2 into 1 very well, so you have to add a decimal point. 2 goes into 1 0 times, but it goes into 10 5 times. 5 times 2 is 10. And if you subtract, you have nothing left. So it's 0.5. Okay, we already knew that it was going to be 0.5. I told you that 1/2 is equal to 0.5. I just showed you why. This is why. And I showed you why using division. And I'll show you another why using fractions. Just using another fraction that's the same fraction. 1/2 is the same as 2/4, right? Yes, it is. It's the same as 3/6, right? None of these really matter. What I'm really looking for one is one that's in the decimal form, and decimals are all base 10. So I need like a 10 or a 100 or 1,000 or a tenth or a hundredth or 1,000. So we're going to try to put it in tens. 1/2 is the same as how many tens? 5 tenths. And the way I would read this is 5 tenths. You hear that THS in my voice? 5 tenths. That's a decimal. 5 tenths looks like this, because this is the tenths place. This is the ones place over here. Tens would be over here. Hundreds would be farther over. And if we go to the other side of a decimal, we go from the ones to the tenths, to the hundredths, to the thousandths. You can kind of hear that I'm pronouncing it extra loud, the THS at the end of each one of the decimal place values. Tenths, hundredths, thousandths, 10,000ths, etc. Okay, so if we can write it as a form of 10 or 100 or 1,000, I can immediately change it to a decimal. This is the fun way. Long division, not so fun, but it works every time. Fraction form is really cool, but it doesn't work every time. Okay, for instance, this is a terminating decimal. Terminating decimals work often. But the other kind of decimal, the one I was telling you about, the repeating decimals, they don't work every time. Alright, for instance, 1/3. If I want to use that, excuse me, I've got a frog in my throat. If I want to use that thing, I have to be able to put it to a 10 or 100 or 1,000 or a 10,000, and 3 doesn't go there. 3 goes into 9. 3 goes into 90. 3 goes into 99, but it doesn't go into 10 or 100. It doesn't go into 1,000 either. It goes into 999. We can't do it with this one. We have to use long division. So we remember that 1/3 is the same as 1 divided by 3, and that's the same as 3 into 1. And it doesn't go into 1 very well, so we add a decimal point and some zeros. And 3 goes into 1 0 times, but it goes into 10 nicely 3 times. 3 times 3 is 9. 10 take away 9 is 1. Bring down the next 0. We have 10 again. 3 goes into 10 3 times. Do you see the 3 times 3 is 9. 10 take away 9 is 1. Add another 0. Bring it down. 10 again. So we had 10 up here. We got 9. We had 10 down here. We got 9. We got 10 down here. We're going to get 9 again. we're going to get 3, 3, 3, 3. It's going to go on forever and ever and ever. This is why it's repeating. It doesn't stop. You can't find an end to it. We write those. 1/3 is equal to 0.3, and instead of writing 3, 3, 3, 3, 3, 3 forever, we just write a little bar over it. This bar notation is to show us that it's a repeating decimal, and the part that the bar covers is what repeats. So for instance, if the answer to a fraction, changing a fraction into a decimal, if my answer was 0.838383, I would write that as 0.83, and I'd put a bar over both the 8 and the 3. But if my answer was 0.833333 forever and ever, I would have to write this as 0.83, and the bar would just be over the 3, because the 3 is the only part that's repeating, not the 8 and the 3. Does that make sense, the difference between this one and this one? I think it does. Okay, so we've got two methods to solve fractions. We can use division, or we can use a fraction factor. A factor fraction of 10. 10 is what we're looking for, or 100, or 1,000. 10, 100, 1,000. Okay, so these are our two different methods, and if we just grab a couple of problems. 1/8. 8 doesn't appear to go into 10. I can't think of how many times it goes into 100. It might go into 1,000. In fact, it does go into 1,000. But it's way out there. So let's not even try. It's going to be easier just to divide. 1/8 is 8 into 1. Add the decimal and a couple of zeros just to make sure. 8 goes into 1 0 times, but it goes into 10 once. 1 times 8 is 8. When we subtract this time, we get a 2. 20. 8 goes into 22 times. 2 times 8 is 16. 20 take away 16 is 4. And then bring down the 0. We have 40. And here's the end of it. 8 goes into 40 5 times, because 5 times 8 is 40. So 1/8 converted to a decimal is 125 thousandths. So if we were to write that as a fraction, it would look like this. But again, that's hard to do. It's not actually easier to do the fraction form of 1/8. It's easier to do the division form of 1/8. Now, it works with 2/8, 3/8, 4/8. However, if you had 2/8, you might notice that that's the same thing as 1/4. Right? And 4, does 4 go into 10? No. Does it go into 100? Yes. Hopefully this is one that you recognize. This is 1/4, and 1/4 goes into 125 times. So I might immediately say what goes into, whoops, I don't want to write a 2, I want to write 100. 4 times 25 is 100, so 1 times 25 is 25. So 1/4 is the same as 25 100ths. So 2/8 is actually the same as 25 100ths, and that can be simply written as 0.25. 0.25 is equal to 1/4, or 2/8. And once you get 25 hundredths, I just know I need the tenths and the hundredths place, and that 25 just flops right into it. Alright, if we try a couple more, 3/20ths. This works great with fractions, 3/20ths, because 20 goes into 100. 20 goes into 100 nicely. 2 times 5 is 10, so 20 times 5 is 100. And 3 times 5 is 15, so it's 15 hundredths. So it just looks like 0.15. This is 15, 0 and 15 hundredths. Okay. Another easy one. This one is super easy, 4/5. That goes into 10. Remember, we're looking for the fraction form, we're looking for 10, 100, or 1,000. And 5 goes into 10 nicely, times 2. 4 times 2 is 8. So 8 tenths. So the fraction form of that would look like this. 0 and 8 tenths. Make sense? All right. Maybe just another couple. 3/7. I have no idea what this is going to look like. 3 divided by 7 is 7 into 3. Add a decimal and some zeros. We just don't know how far it's going to go. Change colors just for fun. 7 goes into 3. Nope. 7 goes into 30. Yes. 7 times 4 is 28. 30 take away 28 is 20. So we get 2 left. Bring down our 0. 7 goes into 20. Not 3 times. That's too many, so we have to go twice. That's 14. And then we have 6. 20 take away 14 is 6. Bring down the 0. Change colors again just for fun. 7 goes into 60. 7 times 8 is 56, right? 7 times 8, 8 times 7 is 56. That's going to leave 40. I have to add another 0. Now this might be one of those that goes on forever. I had 30, 20, 60, now 40. 7 times 5 is 35. Which leaves 5. Keep getting a different one every time. Bring down your 0. 7 goes into 50. 7 times, I keep forgetting to change colors. 7 times 7 is 49. This leaves us with 10, with a 1, which comes down as a 10. And we still haven't repeated 1 times 7. We're going to go to 30. Now we're back to 30, which is where we started. 1 times 7 is 7, which leaves 3, and we'd bring down it. So this is actually a repeating decimal, 428571, and 428571 again. So we'd actually have to put a bar over this. So you're probably not going to find one that looks like this in your homework because it's actually asking too much. 428571 with a bar over it because it's repeating decimal. Kind of crazy. Alright, have fun with this assignment. Just do lots of long division or do fractions, whichever you like to do. Sometimes you can choose. Sometimes you have to decide the right choice is the one that'll work. Okay. Off with you now.